size of the black hole and the size of the galactic bulge that surrounds it. The astronomers wanted to know, is the Milky Way's own supermassive black hole still active and growing? Or has it gone dormant? Just as the black hole at Sagittarius A star revealed its existence, it would show its true colors. The year 2001. Scientists were beginning to work with the recently launched Chandra X-ray Space Telescope. They pointed it at Sagittarius A star, and by chance, at that moment, the black hole erupted. The teams on the ground began focusing on it for longer periods, hoping to see it happen again. And so they did. They saw what are now thought to be flares, outbursts that take place when matter builds up near the event horizon. When it falls in, around once an Earth day, the black hole lights up.
Okay, here we can clearly see a region between those two sources where there is no other object. And here we have the same region, the same two sources, and now in between we see an additional source. So this is a flaring state of Sagittarius A star.
As gas clouds, if you like, come in, they sort of spiral into this innermost regions and get ever hotter before they disappear. And in the very innermost region, just before it disappears from our sight, that's where they would be the hottest. And so an accretion event, think of it sort of a clump, falls into the center, could also look like that.
A group of astronomers is now making plans to get a closer look at these flares, and perhaps to directly glimpse the black hole. From Earth, it is but the size of a grapefruit on the moon. No single telescope on Earth has enough resolution to see something so small, so far away. Astronomers think that they will be able to see it by linking observatories around the world to create what amounts to an Earth-sized radio telescope, known as the Event Horizon Telescope. This simulation shows what they expect to see. A supermassive black hole in silhouette, framed by eruptions on its surface that travel around the monster as it spins.
The reason that this periodicity, the fact that things change repetitively in the same way over a certain time scale, is that the material's orbiting the black hole. And so this time scale corresponds to the time it takes to go completely around the black hole. And so that also tells you how close it is to the black hole. And the key here is that if the black hole's not rotating, if there's no rotating, the shortest period that you should be able to detect is about 24 minutes. So if it is rotating and you think it is coming from the accretion disk, then that's telling you that the black hole's spinning, because material can get closer if it's spinning faster.
Meanwhile, astronomers have mounted a major effort to map the turbulent environment of Sagittarius A star, to shed light on the monster's current state and how it might change. The great space observatories, Hubble, Spitzer, and Chandra, combined to produce the most detailed image yet of the galactic center. In this image, the central zone, 160 light-years across, stretches out like a vast claw. Sagittarius A star is the X-ray hot region on the lower wrist. Out on the hand is a dense grouping of about 1,000 stars, called the Arches cluster. It formed just a few million years ago. Only its tight formation saves it from being torn apart by the intense tidal forces at the center. Below is the quintuplet cluster, with the largest star documented in the Milky Way. The pistol star weighs in at 150 times the mass of the Sun. Large stars like these generate fierce winds of plasma that fill the galactic center. They should provide a steady diet for the black hole and cause it to glow brightly. Monitoring X-ray emissions with the Chandra telescope, astronomers found that these and other large stars are just a little too far away to feed the monster. As gas swirls in, a portion heats up and pushes outward. This outward wind is enough to block much of what's flowing in. So what would cause it to flare up? A separate study suggested that what's falling in is not gas, but comets and asteroids that had been stripped away from stars whose orbits had brought them in close.
This is the center of the cluster, and you know, Sergei's star was over there.
The black hole remains in a state of semi-retirement.
But nevertheless, this is a bit of a puzzle that there are so many of the blue stars.
Will it become active again? Working in the cold, clear air of the Antarctic, one group of radio astronomers surveyed the broader region surrounding the galactic center. Data from their South Pole telescope contain signs that a spectacular flare-up is slowly materializing. A huge ring of gas looms beyond the galactic center. When it accumulates some 300 million solar masses worth of matter, it will reach a tipping point. The cloud will begin to funnel into a second ring that orbits close to the center. This inner ring will condense, then erupt with star formation, before spiraling down toward the ravenous black hole. As the cloud falls into it, the black hole will erupt in a blaze of glory visible across much of the universe. Don't wait around for it. Such outbursts happen every 400 million years or so. There is another much smaller cloud that is now on a black hole rendezvous. The cloud, weighing several times the mass of Earth, approached ground zero. This simulation shows the cloud passing within less than a fifth of a light year. It stretched out as the black hole began ripping it apart. Its momentum will carry most of it swirling past the black hole. In time, it will settle into an orbit and slowly but surely collapse into the center. Meanwhile, on a rocky outpost, 25,000 light years from the turmoil of the galactic center, astronomers continue to watch for surprises. They have found ways to track patterns of change shaping our universe over billions of years' time. And yet, it's often the small and sudden events that feed their sense of wonder.
As bright as this star, or in the extreme cases,
Since they started their work, these groups became the first to witness an object making a complete orbit around the center of the galaxy. The star S2 does it every 16 Earth years. Its dimmer cousin, S102, goes around every 11.5 years. No doubt, over the course of their next orbits, we'll answer many of the questions that swirl around their companion, the supermassive black hole. How did it form and shape the galaxy that surrounds it? Will it one day, from the dim heart of the Milky Way, become bright and powerful enough to light up the universe? How did the universe come to be? Why does it look the way it does? How did galaxies form? Planets and solar systems, life. To find the answers, a series of missions has transported a battery of high-tech instruments above Earth's atmosphere. To peer into the most violent processes in nature and explore the mysterious workings of the high-energy universe. Decades ago, high-energy astronomy was motivated by a number of basic questions. Do supermassive black holes really exist? What are quasi-stellar objects, or quasars? Are they solitary objects in the vast darkness, or are they part of larger structures? In the early 80s, a diffuse X-ray glow was seen filling the night sky. What was it? Bursts of ultra-high-energy gamma radiation appeared almost once a day, lasting seconds, or as long as a day. Are these events nearby, even within our solar system? Or are they extremely distant and highly energetic? Finally, astronomers suspected that supernovae were violent explosions. But what was their exact nature? We now know that they are the final moments in the lives of large stars, and that they are the source of elements that make up our bodies: calcium, iron, carbon, and so on. Because high-energy light does not penetrate our atmosphere, scientists launched a fleet of space observatories designed to capture wavelength bands from gamma ray to infrared. These wavelengths tell us the temperature of matter in an object. Gamma rays and X-rays, tens to hundreds of millions of degrees. Ultraviolet, hundreds of thousands. Visible light, tens of thousands. Infrared, hundreds of degrees. Here is a Hubble Space Telescope image of Cassiopeia A. It shows the visible remnant of a supernova, glowing at about 10 or 20,000 degrees Celsius. Here is an image from the Chandra X-ray Observatory, showing gas heated to tens of millions of degrees. Some of the first images from the Hubble telescope in 1994 captured the galaxy M87. For the first time, astronomers spotted the hot gas swirling around its central region. Knowing the scale of this picture and the speed of the gas, astronomers discovered